Welcome everyone. For today's prep, we're going to look at substitution rule, but this time for definite integrals. And we're really just going to see how do we handle those limits of integration. And there's really two methods that we're going to be looking at. And for today's prep video, we're going to look at just method one. So what we're going to do here is we're going to calculate our integral using substitution rule. And we're going to change our limits of integration. We're going to go from x to u. So let's just see how this works. Let's try an example. So we have this definite integral. We're going from 0 to 1, and those are x values. So we're going from x equals 0 to x equals 1. And the function that we're integrating is 2x times x squared plus 1 raised to the power 5. Now, we see this nice big set of parentheses here and a whole bunch of stuff inside of that. So the inner function here should be our choice for u. So the way we're going to do this definite integral is it's going to start off very similar to how we would kind of start off a regular substitution rule problem. So let's see what we get. Step one, we're going to choose u and calculate du. All right. So what are we picking for u? Well, we're going to let u equal the inner function. So we're going to let u equal the x squared plus 1. So once we choose u, then we want to calculate our new differential. So our new differential is going to be du. And the derivative of x squared plus 1 is 2x. And then we multiply that by dx. So we get our new differential. And then we want to kind of plug in all the regular pieces here, what we would normally do with a substitution. So we see, kind of by design, our u here is going to substitute in nicely. So we're going to be able to fill that in. And then, well, what else do we have left over? Well, we've got a dx in our integral. That matches up with the dx that we just calculated. And then we also have a 2x left over, and that matches up perfectly with what we calculated for du. So this is one of those nice substitutions where everything just kind of matches up perfectly. So we're going to plug in for our new differential. And if we do our substitution here, that x squared plus 1, that's going to become u. So we're going to have u raised to the power 5. And then the 2x together with that dx kind of become our new differential du. So we'll put that at the end. Du goes at the end. Now the question is, what's going to be new here is what are we going to do about these limits of integration? So like I said, these are right now, as they're originally written here, these are in terms of x. So x is going from 0 up to 1. And so the idea with a substitution is we're doing a change of variables. So we want to go from all x terms here to all u terms. So normally our step 2 is we want our u integral. And that means the way we're going to do this is we're going to switch those limits of integration. We're not going to use 0 and 1 anymore. So how do we do this? Well, let's write down our limits of integration. X equals 0, x equals 1. And all we're going to do is we're going to plug this into what we said u is equal to. So we're plugging in to our choice for u, that equation for u. So x squared plus 1. So when we plug 1 into this equation, when x is equal to 1 and we plug 1 in, well, we get 1 squared plus 1. So our new limit will be u equals 2. And then for x equals 0, when we plug that in to our equation, we get 0 squared plus 1. So u equals 1 is going to be our new limit of integration. And when we do this, we just want to keep the order the same. So x equals 1 was the upper limit. So u equals 2 is going to be our new upper limit. And then x equals 0 was our lower limit. So u equals 1 is going to be our new lower limit. So we're going to go from 1 to 2 here. So this is the new part. We want to switch our limits of integration, or let's say we'll convert. So we're just switching over our limits of integration from x's into u's. And from here, and that's bugging me, let's put the 2 on the other side, right? There we go. All right, so we got now we have a regular definite integral here. So now we just proceed like it's a regular definite integral. So we get our antiderivative. So we're just going to do power rule on this u to the power 5. So we add 1 to the exponent, take the new exponent, flip it, put it in front. We're doing a definite integral here, so we don't have to use plus c. But we do put our vertical evaluate line, and we switched over. We're using u's now. So we're going from u equals 1 to u equals 2. And once we have our antiderivative, then we just evaluate. So we get our u antiderivative, like we did. And then finally, for this definite integral, we just evaluate like regular. All right, so how do we evaluate? Well, we take our antiderivative. Top number gets plugged in first. So we'll get 1 over 6 times 2 raised to the 6. Then we subtract, and then we plug in our lower bound. So our lower bound was u equals 1. We plug that in. So 1 over 6 times 1 to the power 6. And that's it. We're done. So this is one way that we're going to see that we can do definite integrals with substitution rule. So we'll see the other method in class, and just kind of a preview. The other method is we leave these limits of integration alone, and so that means we don't have to do this step up front. But the converting step that we ultimately have to do is once we have our u antiderivative, we're going to have to figure out the x antiderivative, and then we'll evaluate. So it's really ultimately going to be the same amount of work, but this is a nice way to do it. We go from our x limits of integration and we convert those into u limits of integration, and then this just becomes a kind of a nice basic definite integral problem. All right, so we'll get more practice with these in class. So we'll see you then. Bye-bye.